All right, let me get the little writing stick here. All righty, here we go. Okay, so when you dilate an image, you will get a similar image. They're not going to be congruent like other transformations. So using these examples here in the picture, these are really, really good. Here's all the definitions you're going to need. So it talks about a dilation. You get the same shape. Notice they're both triangles, but they're different sizes. If you get a larger size, it's called an enlargement. If you get a smaller size, it's called a reduction. And you can see this guy right here, his name is A prime. That's a little tick mark right there. So that means this triangle here is where you started, and that would be called a pre-image. When you, before you have done any type of transformation to a figure, your figure would be called the pre-image. After you have done anything to it, in this case dilate it, then now this new image here is literally just referred to as the image. And if you see the little tick marks, then you can easily identify that that's the image. Alrighty. Scale factor we had mentioned in the past. Scale factor tells you exactly how much larger or smaller your image is. If you have a scale factor that is greater than the number 1, then that is an enlargement. So I can tell you right now, I don't know what the scale factor is. I don't know how much larger this triangle is, but I do know that the scale factor, and we'll call it K for scale factor, is a number that is greater than the number 1 because this is an enlargement. If the scale factor is less than 1, but not negative, so it says between 0 and 1, then you have a reduction. Something has shrunk. And if the scale factor is ever a 1, that would be a trick question because that means you didn't dilate at all. You still have the same figure. It would be congruent. All right. Now, over here, this one shows you everything else you need to know. First of all, you need to refresh your memory on similarity statements because when you dilate an image, you're going to get a similar image. So if I dilate triangle ABC, then I'm going to end up with A prime, B prime, C prime. Whether the vertices are called A prime, B prime, or C prime, they're still going to correspond and be congruent angles. So like this one right here could be called angle E. This one down here could be called angle D. And I would just need to be able to identify the angles that are correspondingly congruent. Because when you have similar figures, remember, the angles that are in the same positions as the original pre-image are going to be congruent. Okay? These guys right there. Now, let me erase some of this because I got a little too much. And remember also about your similar figures, which we just reviewed in the previous lessons, your corresponding sides are going to be proportional. Alrighty, so let me get a different color. Alrighty, so, whoops. All right, so here's the angles we just talked about. Angle A corresponds and is therefore congruent to angle B, angle A prime. Angle B corresponds and is therefore congruent to angle B prime, C, and C prime. And once again, notice where these are located in the similarity statement. That means everything. All right, and here's your proportional parts that we talked about. When you're dealing with scale factor, you have to put the image on top, okay? When you're dealing with dilations, period, it's all about the scale factor. You have to find it. If you have it, you're going to have to use it, okay? So scale factor is image divided by pre-image. So notice I've got A prime, C prime segment. This is a dilated image. It's an enlargement because these have the little tick marks. this side right here is on top, and it corresponds with this side right here in the pre-image. So it's going to be on the bottom. And when I want to find the scale factor, I'll just replace these side lengths with the numbers. So you just keep consistently putting the image on top and the corresponding pre-image side on the bottom. And then you can replace them. So I would put, this is 8 right here. So it would be 8 over 4. That would literally give me my scale factor. 8 divided by 4 is 2. Here I showed you that I picked B prime C prime and divided it by BC. Here's B prime C prime here, 10. No, sorry. B prime C prime here, 6. And divided it by BC here, 3. And I still got the same 2. 8 divided by 4 is 2. So that's how you can find scale factor. Now, you can find scale factor other ways also. I'll show you a couple more ways. And you can use scale factor in different ways. I can use the scale factor to find a missing side. In a dilation, it is literally all about the scale factor. Everything is scale factor larger or smaller. Everything is scale factor distance away. All right, so here is my center of dilation. You have a center of dilation. From that center of dilation, that's how the dilated image is moved farther away from your pre-image. Okay, so this right here, whatever this distance is, and it's labeled A, if I multiply this distance times the scale factor, which we found to be 2, I will get the distance of how far the image is away from that center of dilation. And that's where they got the 2 times A. And that's the same with the rest of these as well. If I knew the distance from center of dilation to vertex C, whatever it is, I could call it X. If I multiply that number, or in this case, this variable, times the scale factor of 2, I'll get the distance of how far away the C prime is from that center of dilation. If I had a missing side, say we didn't know that this side right here was 10. Once again, I need a little bit of more space here. I can use the scale factor to find a missing side. So if I knew the scale factor was 2 and I had these other sides, I would use 2 of these ratios to determine what the missing side is. So I would use the side AB prime here, this guy right here. I'm going to use this one because I have to find this side. And then I'll just pick another one that has all the numbers in it, like this one right here and this one right here. So I'm going to use these 2, and I would put the numbers in. A prime C prime is 8 over AC, which is 4. And that's equal to the B prime, A prime, B prime, which is the unknown. I can call that, we'll just call it like X or whatever. X over the corresponding AB, that's this side right here, and that's 5. And you can cross multiply. You can put this in Desmos like I had showed you before. You put this side in as y equals, you put this side in as y equals, and it will, where they intersect is going to be your value of x. Or you can just cross multiply. This is 4 times x is equal to 8 times 5, which is 40. And then you divide both sides by the 4, and you'll get the 10, which we already know that answer is. So that's another way you can use scale factor. So scale factor is extremely important. And all you have to do is divide the image, pick a side, and divide it by the pre-image, pick the same corresponding side, and you'll get the scale factor. Down here at the bottom is what I already went through. So it says here, here's how I showed you when I cross multiplied. It's showing you how the larger or smaller the image is compared to the pre-image. Here, instead of doing the cross multiplication, it just multiplied. It took the 4 right here and multiplied it times the scale factor and got the 8. 4 times the scale factor of 2 equals the 8. This is where I was showing you how far away the center of dilation is from the vertices. And for this, this assignment here, your center of dilation should be at the origin, meaning 0, 0 on the coordinate plane. Down here, this very last sentence, that's important too, because your center of dilation is at the origin. Let me see if there's any other pictures. Center of dilation is at the origin. If you had a coordinate and you needed to find other coordinates. So here I'm showing you I have the coordinates for the pre-image ABC, and I needed to find the coordinates for the A prime, B prime, C prime. All you would have to do is take your pre-image coordinates and multiply both the X and the Y coordinate times the scale factor. So this is -2 times the scale factor of 2, -4. 4 times the scale factor of 2, +8. And you can do that with each one of your pre-image coordinates to find your image. All right, let's see what else we have here. And this is just reminding you about the center of dilation. Here, if the center of dilation is here at C, for example, and you have this point called P, whatever that distance is, it's labeled here to be at the letter D. Whatever that distance is, your new image coordinate or point is going to be times the scale factor away. So if this was a length of D, D times 2 would be how far away the new image is from the center of dilation. And it's the scale factor is not always 2, even though I keep saying 2. All right, over here, it's the same thing. It's just showing you the difference between an enlargement and a reduction. And you can tell this is an enlargement because it has the little tick marks. And it's just a small replica of above. And it's showing you how it got the scale factor. It took the side CP. No, it took the length, CP right here. CP prime, the length of the distance from the center of dilation to the image to be 5, and it compared it to the distance from the center to the point on the image, and that's how I got the scale factor. Same thing over here. All right, so it looks like your first question has to do with vocabulary, and when you are dilating, when you dilate an image, you do not get a congruent transformation, okay? You get a similar transformation. So that should help you with that vocabulary down at the bottom. You do have to remember the difference between congruent figures and similar figures like we have discussed in the past. What else you got down here? This one says that you started with this coordinate and then your new coordinate is here. So how did you go from here to here? So this would be your X prime. So you have to just work backwards. So let me show you how to do that. So if I need my marker. Give me a second. Uh-oh. 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 I clicked on dilation on the coordinate. Alrighty. I need my marker here. Okay. So if you needed to find out what the scale factor was and you had two coordinates, your pre-image and your image, you're going to do the exact same thing to find the scale factor. You take your coordinate of your image and you divide it by your coordinate of your pre-image. It's all about image over pre-image. That's the scale factor. It's all about image over pre-image. So here I'm just going to choose either the X or the Y. It doesn't matter which one. That's your X and the Y. So I'm just going to choose the Y. So I'm going to take the Y value of my image and compare it to the Y value of my pre-image. And once again, there's how we get that scale factor. Everything has to do with the scale factor. All right. Next question. Let's see what we got here. I can't click on that. The next one. What is the new coordinate of point B prime? Okay, so this time it gives you the scale factor. So you have to find the coordinate that it's asking you about. And then, like I showed you up here, if you have a coordinate, give me a second. Let me get my little marker dude over here. If you have a coordinate for your image and you need to find the coordinate, for your pre-image, and you need to find the coordinate for your image, then you just take both your X and your Y and you multiply it times the scale factor, and you will get, whoops, scale factor was 2, not 3. 2. That's a 2. There we go. Times, that's multiplication. And then, oops, okay, I gotta fix this. And then you do the same thing with the X value and the Y value, do the same thing. All right, so -2 times the scale factor of 2, that'll be your new X. And then 4, which is the Y value right there, times the scale factor of 2. And you do the math, and that's how you get your A prime, B prime in this case. That'd be -2 times 2 is -4. 4 times 2 is 8. All righty. All right. Okay, this one says you got a scale factor of 3, and it wants to know what is the length from the center of dilation to B prime. If it gives you the length from the center of dilation to point B and the scale factor of 3. And I just explained that one above right here in this picture, so refer to that. But I used O to A prime. Everything scale factor away. All right, and then the last question. Similar picture and looks like a similar question. So this is asking you the same thing, but giving you different numbers. Okay, so refer back to this picture right here on that. All right, and then if you need it, you've got these practice, and you've got some notes and videos and cool pictures. So let me end this.